Alright, shortest matching substring. So we have a string S and a pattern P, where P contains exactly star characters, exactly 2 star characters. The star in P matches any sequence of 0 or more characters. We want to find the shortest length substring in S that matches P. If it doesn't, then -1. The empty substring is also considered valid. So if I have something like this is a good example. In that case, this is S, and we are having a pattern that is having BA star C star, all are small case or lowercase, BA star C star CE. Here, in this case, we are going to have exactly 2 stars, not 1, not 0, not 3, exactly 2 stars. So we can have 3 segments if we carefully look at it. The first segment will be BA, second will be C, third will be CE, right? And we want to find the smallest substring that will make this valid, right? That will basically be something like BA. Next is C, so we can have A as a star, C, this is good. Then we are looking for CE, CE is here. These 3 can be a star, so the entire length will be this one. The size will be 1, 2, 3, 4, 5, 6, 7, 8, 9. But we have something smaller, so we are going to choose that. That something smaller will be BA, C, and CE, right? Only 3 extra characters, the remaining are the ones that were already in pattern, right? So if we don't have a match of BA or C or CE in the entire string S, in that case we return -1, right? There can be other scenarios also, right? Something like this BA, instead of this C, we are choosing this C and then CE, right? So they can be different combinations, but the common thing is we are looking for the segments, right? And that can be optimized. Since this is a hard, right? We have 10 power 5, right? So we can't go of n square, right? We have to be O of n log n or O of n in best case. So we are looking for something like rolling hash, or we can do this problem using KMP as well. KMP suits very well here because these are nothing just patterns, right? And we are looking for these patterns inside the string, right? So for every segment, we have only 3 segments. So we have 3 patterns. So for every pattern, I can create a LPS, right? And what is LPS? Longest prefix suffix length. I think that's what it's called, if I'm not wrong. It's basically an array that denotes, uh, let me write this down. LPS of I is nothing but from 0 to I, what's the longest prefix which is equal to the suffix. This is what it is. So I'm not going to explain KMP here, but that's a must for this question. We can do it using rolling hash as well, but this is the concept I'm going to use here. So this LPS can be created for all the 3 patterns, and for suppose BA, what's the LPS? That will be nothing but 0, 2, because at this point 2 length matches, right? So we are going to put 2. We can take different formats for this one. LPS can be a own array of the size pattern itself. We can have a length here. It's just going to make our lives easier by finding the matches. Now, how are we going to store that matches, in what data structure, in what format? That depends on us, right? So instead of storing it like this, I can store it something like this, right? At this point, we have a match of length 2, and that's the first segment. Second segment will be a match here, right? Then again, the first segment is going to match here. Second segment is going to match here. And finally, the third segment is going to match here. That's the, my bad, my bad. So we are going to have separate segments, right? Separate arrays. So that the LPS of BA is not going to, or something like the LPS of C is not going to hamper the LPS of CE, right? Or CEC, right? If we had something like CEC and C, in that case, we shouldn't have both the LPS in the same array, right? Obviously, we need different LPS for different patterns. So my bad, all these should be 0, 0, 0, 2, 0, 0, 0, 0, 0, 0, right? This is the LPS of BA. For segment 2, this is the LPS. For segment 3, this is the LPS, right? So these are the LPS, right? Now how can we use this to get our answer, shortest substring? Well, we can have different techniques on this. We can have a binary search on this. That'll be O of n log n. But we can do better. We can have a three-pointer approach here. So if we have a I here, a j here, and a k here, all at 0, then we are going to take the I, move forward. As long as we don't have a match, we keep continuing forward. As soon as we have a match, then I'm going to take j, move forward. What's the condition to move forward? The length of the second segment plus I should be less than j, right? So at this point, I is at 0, 1, 2, right? I is at second index. We have a length 1 for the second segment. So the second index plus second segment, that is second 2 plus 1, is, this is the starting point, right? This is the point we started. We start the j, we keep continuing as long as we don't find it. We find that there is a match, then this is one of the valid answer. Now we move k, we keep continuing. Similar condition here, j plus third segment length, that is 0, 1, 2, 3, 4. 4 plus 2, 6. So k should be greater than 6 at least. 0, 1, 2, 3, 4, 5, 6. So k should continue here. Now it will continue as long as I don't find the match. I found the match, so this is a valid scenario. 2, 1, 2, right? Now we have some things in middle. So basically k plus k minus I will be the length of this point to this point, but we want this point as well, right? We want the length. This is the ending index of the length or the segment, right? But we need that segment as well in our substring length. So k minus I plus the length of the first segment is going to be our answer, right? So that's the problem, and that this is how we are going to solve it. So how we are going to calculate LPS? That's using KMP. So I would urge to learn KMP before solving this problem. Or rolling hash is also an option. And how we are going to solve it, let's have our steps. First step is to get the groups. For every group slash pattern, get the LPS, right? For now start a 3-pointer approach. All right, that's it. So the first step will be creating the group. Let's have a group 2, group 3. Here we are going to create the groups, right? But we want to know that which segment or which group string that we are going to get between the stars, right? Which group this string belongs to, so I can have a count. Initially the count will be 0 0. Here the count will become 1. So as long as the count is 0, then it goes to group 1. Count is 1, count becomes 2 when I see a star. So where the string, when the count is 1, then this is the group it belongs to. And similarly uh, 2 as long as uh, the string is exhausted, whatever string I have, that belongs to group 3. So it's straightforward, probably difficult to explain, but code wise it will be easy. Alright, we need to enumerate. Let's get the character. Here if p is equal to star, then increment the count. Else if count is equal to 0, then the group. So if count is equal to 0, then I am forming. In the else part, I'll always be forming the string, nothing else. So count plus equal to p of I. If count is equal to 1, then this should be group 2. If count is equal to 3, then this should be group 3. Straightforward. At this point we have the group, so I'm going to get the LPS, or let me call it matching indexes, which is basically this format. This vector is what is going to be this. So it's going to be 3 in number, right, for every segment or group. So let me call a function to get this. This is going to take group 1 and S, and this will be group 3, group 2, this will be second, this will be third. Alright, so let's create this function first, because that's going to be needed. So vector of int, this is going to be string pattern, string s. So let me also have a vector here. This is going to create a vector, right, of this length. So of this length, right, so that will be a length of s. So let me call it match indexes of what size, this. If pattern can also be empty, right, there can be scenarios like this star a star, right. We have 2 stars, but group 1 and group 3 are 0, so pattern can be 0. So if pattern.length is 0, length is 0, in that case it's safe to return the match indexes as is, right? Otherwise we get the LPS. So this LPS is basically we'll see, let's see, it's literally this array, that's what I'm talking about for the pattern, and then I'm going to convert this to this. So basically I'm going to get the LPS, which is going to just take the pattern, and that's it. So this pattern's LPS is going to be determined by this function. So let's create this function and then let's move forward, and that's also going to be a vector. My bad. Here this will be LPS of size pattern dot length. This pattern dot length, see, for LPS of 0 it's always 0, right? That means 0 to 0, a string doesn't have any character from 0 to 0 of pattern has 0 LPS, right? So I will start from the first index. The default values are already 0, so I don't need to override that. Initially the length will be 0 because that's the longest LPS that we have found, longest length till now. This will be continuing as long as I have not exhausted pattern completely. If pattern of length is equal to pattern of I, that means I have found a let me create an example for this. So the prefix, longest prefix at this point will be 0. This is the LPS. From here it will start. So I am here, this is the where I is currently, and I'm going to see that the pattern of length, that is A, is equal to pattern of I, that is A, is equal to pattern of length. Length is 0, so pattern of length is this one. This and this are equal, so I'm going to increment the length and assign that to the LPS, right? So increment the length, assign that to the LPS, and increment I as well, right? Finally here the else condition is going to be interesting. So this will be 1, this will be 2, these are all this if condition actions, right? This is something that things can go in the else case. In the else case it's going to check that LPS of length minus 1, that is LPS of length minus 1, that is at this point length is 2, so LPS of length minus 1, my bad. Yeah, so I checked that this A and C are not equal, so I'm going to check LPS of length minus 1, that is 1, and assign that to the length, and now this A and C is going to be checked, right? So essentially what I'm checking is LP, I'm assigning the length now to LPS of length minus 1. Length was 2, length minus 1 is 1, so LPS of length minus 1 is this one, right? LPS of length minus 1 is 1, and that's going to be only valid if length minus 1 is greater than 0, right? So if length is not equal to 0 is also fine, greater than 0 is also fine. I'm going to have this, and if length is equal to 0, that means I have reached this point and I don't have a match, right? So I'm going to assign 0, which is already assigned as a default value, so we don't need to override that, and increase I, right? And do the same process back again. So if this is not true, else I plus plus. That's it. That's our LPS, and we can safely return LPS from this point. Now comes the part to have this format, right, from the LPS. How are we going to do that? Well, that's straightforward. First, we are going to get the LPS that we have already done. I is equal to 0, j is equal to 0, right? So yeah, so this will continue as long as s dot length s is not exhausted, and if s of I and pattern of j, if that matches, in that case we are going to continue I plus plus and j plus plus, right? So and if b and b matches, in that case what we need to do is increment j and I, right? So if s of I is equal to pattern of j, in that case increment j. So if we are incrementing j, we need to make sure few things, because if pattern dot length is reached, in that case we need to update the match indexes. We have found a match, right? So we can update the match index. Where to update, what index to update to, right? Since we have incremented I, uh, technically what we can do is we need to increment I, but before that we need to increment both I and j, but we increment j first and then I, so that I can use I here and update the match index of I first before incrementing I, right? What is going to be updated? The length of the pattern, because that's where uh, because j has been exhausted, that means the entire pattern has been found in S. That means I need to update that point, which will be similar to this point, update it to the pattern length. So that is going to be the update pattern dot length, right? And lastly, since has been exhausted, I need to take j backwards, right? And that is where LPS is going to uh, take into its own hand and take j backwards. How it's going to take that is basically exact same thing that we did here. I missed the semicolon. Length is equal to LPS of length minus 1. Here the length is basically j. That's the index we need to take back. We were taking back length here, we are taking back index here, basically using LPS like this. I'm sorry. And if the match has not happened, then there will be a else condition, and that else condition is going to be exactly like this, right? If length, that is j, is not equal to 0, then keep taking j backwards, Otherwise, if j has been reached to 0, in that case, do I plus plus. That's it, straightforward. Now we have our match index. We are going to take match indexes and return that. Now we have all the match indexes, right? We are going to perform the three-pointer approach that I was talking about, that we have already did a dry run here. So I'm going to have 3 pointers, and this is going to continue. Before that, let's have an answer. Initially, let's have it int max because that's what we need to minimize, right? So this is going to continue as long as I have all 3 groups within limit, right? And by that I mean I plus group dot s dot length. Let's make things simpler by having lengths because that's going to be used a lot. So let's have segment 1. Alright. So at this point, this is going to continue, this while loop is going to continue, and I'm going to return here result, but on a condition. If it is already, if it's still int max, then I'm going to return -1, otherwise result. So at this point, this while loop is going to continue as long as all 3 groups are within the range of s dot length, right? So let's also have n as this. So as long as I, that's the index, plus the segment 1, segment 2, because I is going to represent what? Is going to represent the end of group 1, right? So it's already having the weight of or the length of group 1 by that point. If we add to it group 2 lengths and group 3 length, and this is going to exhaust s, only then we'll continue, otherwise we're not going to continue, right? Now we are going to basically move move I first, right? We are at 0, we move I as long as we don't find, or we find a match, right? So while I is less than s dot length and match indexes of 1, because that's the LPS of the first pattern to which I belongs, right? I belongs to the index of the first pattern. So match index of I is not equal to group 1 dot length, that is segment 1 essentially. If it's not equal, then I'm going to increment. Now since we are incrementing, we need to take care of the boundary conditions because we have not taken care of that here. So if I is greater than or equal to s dot length, that is n, I can use n here instead of s dot length. So if it's greater than or equal, then break, right? Now that I is at a point where it's matching, then I'm going to move j. How am I going to move j? Well, first I'm going to move j like this. Actually, I can move j. Yeah, exactly like this. So I can copy this down, but just have a different condition. So as long as this is true for j and match indexes of 2 of j, that is the group or instead of this I can also uh, yeah, segment 2. As long as this is not matching, I'm going to continue, or this is not matching. Right, J, actually let me make things simpler. So first I need to jump J to a point where it's start being valid, right? So I'm going to jump J from I plus the length of segment 2, right? Length of segment 2 was 1 here in this example. So from here it will start being valid. So I plus this point, but I has been incremented uh, let's see, I has been incremented till this point. So I is at a point where it's going to match its length. So this is where I is, not here, but here. That's what I was making sure. So now J will reach here, and from here I will start continuing, right? So I can take J, save some condition, take J to I plus segment 2 length and do this, do a J plus plus here, right? And check if J is greater than equal to N or not. Now I'm going to do the same thing here, take K to a point where it is valid with segment 3 length, and things are going to be correspondingly changed for K and segment 3. This is 3, this is K, this is K, this is K, and lastly I am going to update the answer or result by minimizing it to what? K minus I plus segment 1, because that's what we wanted. K minus I plus segment 1 length, and we are going to increment answer, sorry, I, right? And that's pretty much it. If things are right, this should work. All right, this should be P, not CH. Okay, I think I have to update this CH. Let's see now. Okay, I don't need a I, my bad. Okay, match indexes 1 of I is not equal to segment 1. This is right. Matching index, I'm sorry, let me make this match. Let's see now. Okay, result is, oh, this is answer, so let's update result here and see if now it works. Sorry for the silly mistakes. Pattern to pattern. You know what, let's print it out, the things that we want to have. Alright, let's copy this, copy this, copy this for match indexes. Let's see now. Okay, this is correct. This is correct. and this is incorrect. Alright, so things that are going wrong is somewhere here because the last string or the last group is not complete. That's not correct. Let me see group 3 if that's correct or not. Seems like it's not correct, but let's make sure that that's where the things are going wrong. Yeah, that's where it's going wrong, right? It's not printing anything. Group 3 is where things are going wrong. My bad, this should be 2, not 3. I'm sorry for the silly mistake. Now let's see if this works. Alright, let's submit it. Oh shoot. Uh, Interesting. Instead of having the length here, if I have it as a condition of the exact same thing, will that make sense? Will that work? Match indexes 2 of j is representing, actually this is not needed, j should be less than I plus segment 2 length, right? Similarly here, instead of having this, k should be less than j plus segment 3 or this. Now let's see if this works. This should improve the time complexity. I was actually breaking the 3-pointer concept, and let's see if this works. Yeah, this works. Time complexity wise, this will be LPS, so this will be basically O of m plus n for every string and pattern, so for every pattern, and overall this will be O of n, so technically it's O of m plus n time complexity. Space complexity will be O of n plus m, I guess, because we have both LPS and S. So that's the problem. Thanks.